First of all, I want to welcome you all to this advanced Windows 8 session using XAML and C#. My name is Kevin. I work at Real Dolman, and my job there is typically technical consultancy. So what I exactly do depends on what the client wants, typically. But I've been working with .NET since the beginning, more or less. I come from a web background. I started with ASP.NET afterwards, went over to Silverlight, and now Windows 8. And next to that, I do solution management on Windows 8 at my company, which more or less means that trying to get the company ready for developing Windows 8 applications. Now, this is an expert class, so the first thing that would be interesting to know is what you guys' backgrounds are, just to know what I have to talk about, what I have to go deeper into. So have you all been working with Windows 8 and XAML and C# already?
XAML, no, yes, but Windows 8 not yet.
XAML, yes, Windows 8 no. So that's WPF. So you know about MVVM?
Yeah.
Is MVVM new for any? No, a bit.
I only have experience with Windows Phone 7.5, and then I follow some internet sessions about Windows 8.
Okay, so Windows Phone and internet sessions on Windows 8. Okay, so I guess most of you are more or less have been busy with C# and XAML already. Okay, so that's good. We will need a Windows 8 machine with Visual Studio 2012, just for information. A lot of this training is hands-on exercises, because, well, in my opinion, that's the best way to learn, of course. But I'm here all day, so even during the exercises, just ask if you want to know something or if something isn't clear. So, let's have a look at what we're going to talk about today. So we'll start with architecting, at least setting up your application with MVVM. That's the basics of any Windows 8 XAML application, in my mind at least. It's more or less a de facto standard pattern.
Can we get the slides later on?
All the slides, all the exercises. I think Microsoft will make them available through their site. I'm also going to put them on my blog. I asked if I could do that. So that will be on there tonight probably. So we're going to start with MVVM. Of course, MVVM alone, you can give a session of a full day on that. So I have to keep it a bit short. But I think most of you already know most about this one. Then we're going to look into implementing offline mode. There's quite a lot to that. It's not only detecting whether you're online or offline, it also includes an easy way to handle exceptions or general exception handler service. And we will also see how we can save data to an object store. So save your data locally, use that data when you're in offline mode. And when you go back online or when you're online, when you have access to your services, use that instead of the object store and save accordingly. Then we'll have to look in process lifecycle management, of course. So suspending your app, getting back from a suspended app to a running application, getting back from a terminated app to a running application. How can you handle that and what are some best practices on that? And then there's a bunch of advanced XAML tips and tricks. This means implementing a semantic zoom, variable sized grids. That's a question that pops up a lot. So we'll look into how exactly you can get your grids to have variable sized blocks of content. And we'll also look in using a data template selector in Windows 8 application. So semantic zoom. Another important part of a good Windows 8 application is a live tile. So to make your application feel alive. We'll see how we can implement that. There's actually a bunch of helper classes for this to make this easy. And now once you got a live tile, it's often a good idea to look into background tasks and triggers on how to start those background tasks. to ensure, for example, your live tile can be automatically updated when your app isn't running, or even to do some other more heavy work you want to do on a regular basis, or depending on triggers from your system. So that's the background task, and it also includes lock screen batches and the difference between them, because if you have your app on lock screen, you actually get more CPU cycles and seconds to do background tasks. And then there's a few recommended service access approaches. Although I don't think that will be new for most of you, because actually if you've used Silverlight, the networking stack in Windows 8 app is, let's say, about 90–95% the same. So that's not really really new for most of you. But we will look into what is supported and what is not. And after that, if we have some time left, I doubt it, but you never know, I also have some extra content. Incremental loading is one of it. A bit more info on async await, and a bit more info on how you can run tasks in parallel and wait for one or all tasks to complete, stuff like that. But even if we don't get there, all the exercises will be made available afterwards, including these slides. Normally, we will have a break before noon, lunch at, I think, around 1:45. They're going to give us sandwiches, I think. That'll be an hour, and in the afternoon we'll also have a break, and we should be ready at 5. Okay, so model view, view model. What is model view, view model? Let's start with that. It's actually a specialization of a pretty old in quotation marks, pattern. That's Martin Fowler's presentation model. As you will see, model view, view model is largely based on model view controller. It has a lot of things in common with MVP, MVC, and it's typically used in XAML applications. And why is that? Well, in my opinion, it's to leverage the real power of XAML. You've all worked with XAML, so you all know about data binding. What we often see is that people start working with XAML applications, start programming, and still work the old way. Like you have a list box on your screen. What do you see? People are gonna get their data in code behind and then do stuff like my listbox.item source is this collection. That actually means there's a lot of code behind if you work like that, which makes that code harder to test. It's not really good for separation of concerns either. So we needed something new. When XAML applications started to emerge, the MVVM pattern started to emerge as well. And in essence, if you look at it in a really simple way, what MVVM is that you have got a view model, which is actually the data context of your view, and you use bindings to connect properties from your view model to your view. And your view model, in turn, can connect to the model, get the data from the model, get the data from the services, turn that into the model, and change that model around, or convert the stuff it gets back from the services to ensure your view can work with it. If you look at it in a very simple way, that's more or less all there is to it. But that's a very, very simple way. But that's the basics. And these two images actually make that quite clear. So you always get your view model, and your model. Your view is connected to your view model through data binding, so just properties on your view model that are bound to visual elements on your UI. To get events from your view to your view model, you would typically use commanding, supported out of the box by anything that inherits button base in Windows 8. And your view model exposes the model to the view, very simply put. Now, if you go into that a bit more in detail, a model, what is a model? Actually, it's an object representation of your data. What we often see is that there's actually an extra layer in between. So in a lot of smaller applications, you would typically have your view model access a service, get data back, and convert that in some way to make it available to your view. In bigger applications, there's typically some kind of service agent in between that, where your model, which in the simple applications can often be seen as exactly the data you get back from your services. So let's take, for example, a very simple web service, WCF service. What you do right-click, add reference, and a lot of stuff gets generated. In a lot of applications, that generated data, those generated classes, proxy classes, are used as a model. That's what happens in a lot of applications, and that's actually quite a good approach for smaller applications. If you start looking at bigger enterprise applications, there's often a layer in between that that even converts the data you get back from your service to your own model, which makes it easier to work with from your view model. It really kind of depends on how you architect your application. There's even other ways. I've been on a project, for example, in which they use a portable class library, if you've heard of that one. Portable class library is a project template. It's actually a plugin. You can just download it on Visual Studio Gallery. It's a project template that enables you to share code between applications or between projects that are compiled against different versions of the CLR. So for example, you can have a portable class library that you can have a portable class library, and that portable class library can be referenced by a full .NET 4, .NET 4.0 project, can be referenced by a Windows Phone project, a Silverlight project, or a Windows 8 project. So what we had in one project, at one client, was that they had an extra layer, and they referenced that layer both on their server side and on their client side. And those were the objects they communicated through, and not the ones they got back from the automated proxy generation. By the way the portable class library does its trick is it's actually by only allowing you to reference the common possible namespaces and classes between the projects you want to target. So a model, object model, is a representation of your data state content. To view, as we have seen, through UI, your XAML code typically. And the view model is responsible for changing that model around in such a way that the data is usable by your view. So we all know about converters. We've all worked with XAML and C#. Some people like to call a view model a converter on steroids. And if you look at it in some way, that's actually possible. That's actually true. I've actually seen projects in which no converters are used. At some point in a solution setup, the architect decided, nope, I don't want converters. I want my view model to be responsible to change the data in any way I need it to be changed to be used by the view. So why do I tell all this? Well, actually, the point is that there's a lot of different approaches to MVVM and a lot of different implementations of it. And it's very hard to say that this is the good one and that's a bad one and that's even worse. It all kind of depends on, well, on the project you're on the requirements of the project. And like that, we easily get to this. Why would you use MVVM? A few things that just type in MVVM in Bing, let's say, and a few things that immediately pop up: separation of concerns, code maintainability, testability. Those are the typical ones. those are quite logical as well. Code maintainability, testability, it's a lot easier to test a view model, which you might even put in a separate project with only your view models. It's a lot easier to test it like that than to have all the code in your code behind of your view, of course. Separation of concerns that you get out of the box, actually. Now, then you immediately get to the next question. If you do not want, if you're using MVVM, what about code in your code behind? Can you have code in your code behind? Can you not have code in your code behind? How far do you have to go to adhere to the pattern in function of your project requirements or your architecture requirements? That's actually a pretty important question. There are people who say there should be absolutely no code in your code behind, none whatsoever. That often results in people creating services to show a dialog pop-up, for example. So you can, from your code, from your view model, say, well, dialog service dot show me this pop-up. That means that, of course, there's no code in your code behind of your view to show that pop-up. Same goes for navigating. Navigating is another important one. It's also a lot of discussion about that. Can you, is it still, is the pattern still valid, or are you still adhering to your pattern if you start calling code in your code behind to navigate to another view? Does that comply to the pattern? I like to take a bit of a pragmatic approach in this. You can write code to ensure you can navigate from your view model. It's actually not that difficult. The question is, should you? In the approach I often take of MVVM is that I want my testable code and my algorithms and my logic to be testable and to be separated. But I don't necessarily want code that is essentially or inherently UI related. I don't necessarily need that to be in my view model. I used to think that it should be done that way. But the approach I tend to take now is a bit more pragmatic. For example, firing animations, that's inherently UI code. Should you go through a lot of hoops just to ensure you can get that from your view model? Some people say yes, some people say no. I say, well, let it depend on your project requirements. But I guess the general idea is keep the, how do you say it? Keep the reason you implement the pattern in mind, and don't try to implement the pattern no matter what, even if it's outside of the reason you want to implement it. If the reason to implement the pattern is separation of concerns and testability, then in my book it can be a good approach to keep animations, triggering animations, or even navigating to another page in the code behind instead of going through a lot of hoops to get it out of there. But as often it depends on your view on it and your implementation on it. Now, how do you go about implementing this stuff? Basically, very, very, very basically, a view model is a class that implements iNotify property changed, and that's all you need. Very, very basic approach. Why do you need this iNotify property changed? Well, we've all worked with XAML. You need to be able to notify the UI, the bindings. Now, of course, if you go about it this way, you will very quickly run into a few problems. For example, if you just make a class and implement iNotify property changed, how do you go about communicating between different view models, for example? It's quite easy to imagine a case where you have one page. Oh, let's say, I'm going to think of an example here. Let's say you're building Facebook, and you've got a page where your user can read his private messages. Your user can read his inbox. And while your user is reading the inbox, every time he reads a message, that message is now unread. So instead of being, it's now read instead of being unread. If you look at Facebook, has on top of its UI has those little icons that show you how many notifications you have, how many new messages you have in your inbox. Now imagine you want to implement that, and you could typically say, okay, I have an application and I have a header in that application. That header is one view, and that's tied to a view model. And somewhere in my page, I have somewhere in my application, I have a page that shows me my inbox. And once I start reading my inbox, all of a sudden my message becomes read instead of unread. That means that if you have a header in which a little box and an icon next to it showing the number of unread messages is, then you somehow need a way to communicate between the view model that's behind your inbox and the view model that's behind your header. If you want to keep those separated, you of course do not want hard references in one view model to the other view model. So you need a way to communicate. So that's one thing you don't get out of the box. Another one is commanding. Commanding support. Command is something that implements the iCommand interface. The iCommand interface is included, but an implementation that's not included. You'll have to write that yourself. So yes, you can go ahead and start implementing your own MVVM framework. But there's actually better options out there already. People have done that for you. One of the things when you start architecting your app and you start thinking about how you're going to set up your solution architecture is look around at what's already available. Don't try to implement everything. Don't try to reinvent the wheel. One of the frameworks I like best, it's probably a personal preference, is MVVM Lite. Anyone heard of that one? I guess everyone. Anyone used that one? More or less. MVVM Lite was quickly adapted for Windows 8. So what does that include? It includes, of course, the base classes you need. It includes support for commanding, so you have relay commands, implementations of the iCommand interface. It includes support for messaging. Messaging is a way to communicate between view models without those view models, or communicating between parts of your code without those parts of your code knowing about each other that they exist. So it's a general register, subscribe and send pattern actually. And there's also a view model locator included, which enables you to easily bind to your view model to connect your view to a view model. I'm immediately going to show you that one. The nice thing is that MVVM Lite also includes a simple IOC, which is, as far as I know, or was, as far as I know, the first inversion of control container for Windows 8. And the thing I actually like best about MVVM Lite is, well, the name more or less says it, it's very light. It includes what's needed to get started, but it doesn't include a lot of the unnecessary things you might get in other big, huge, bloated frameworks. And it's open source, so you can do more or less what you want with it. So, I already said a word or two about the view model locator. That's actually a way to connect your view to your view model in this case. What's the view model locator? It's actually simply a class with a few static properties, and that view model locator is made accessible as a static resource through your app XAML. So by doing that, your view model locator is instantiated. And once one of those static properties is accessed, which is done by binding it to the data context of the view you need it in, the simple IOC container ensures one instance of that view model is given to the view that needs it. Now, this is also an interesting thing to just go a bit more in detail to. How many instances do you want of your view models? That's one of the questions that often pops up. Some implementations or some people also, depending on how you need to set up your project, go for, well, every time a user navigates to my view, I want a new instance of my view model. That's one of the things that happens sometimes. Well, the good thing about this, you always get a nice new instance. You don't have to worry too much about cleaning that up. The bad thing is, well, you more or less are recreating a web application like that. It's stateless all of a sudden. If on the other hand you say, well, let my IOC container create one instance of a view model, and every other time that instance is that property is needed, give me back that same instance, which still contains the state of that page for you. That's more or less the way I would suggest to work. Reuse the same view model instances. Now with this simple IOC container, you get it by default. So once an instance is created, that same instance is reused. If for some reason you do not want that, you can get it as well. It's just stating that you want a new instance. Another interesting thing this IOC container enables you to do. I don't know who has worked with this MVVM Lite in Silverlight. There used to be implementations of this without the simple IOC container. And that meant that your view model was instantiated the very first time it was accessed. The problem was that sometimes you would have code that would send messages to a view model before the view model was instantiated, which means the messages never arrived, which means your view model couldn't execute the code that it had to execute. Well, through this simple IOC container, you can now state, okay, well, at the moment at the moment my view model locator is instantiated, immediately instantiate the view model, so that every message or every communication that should be that should arrive actually arrives. Again, whether or not you do this will depend on your application. You can, for example, imagine that you want to ensure that a few view model instances are created, being the ones that, for example, belong to the default module your user will end up in. But imagine you have an application which consists of an employee management module, and next to that a reporting module. Well, you would typically not want all those other view models from the reporting module to be instantiated if your user is never going to access them. So again, that more or less depends on how you're going to structure your application. Don't worry, I'm going to show all this in code in a few minutes. So we now know how to ensure our view models are created. We know how to connect them to our views through the view model, to the view model locator. Now there's commanding. So if you want to ensure your click handler, for example, doesn't go through the code behind of your view, but immediately to the view model, you need some way to ensure this is possible. In XAML, this is done through commanding. What that allows you to do is you can now not only bind item sources or text properties, for example, to properties from your view model. You can now also bind command to a command you define in your view model. Now, everything that's inherits from button-based supports commanding by default. A command is anything that implements iCommand. MVVM Lite actually has implementations for this called relay command. It's a generic implementation. Relay command T, the T is for the parameter you passing. Actually pretty nice implementation. But there's a few other times you might want to handle events. Take, for example, something that doesn't implement button-based, and something that we tend to see a lot is the selection changed event of anything that has an item source. Selection changed event of a list view, for example. I've seen a lot of code in which you need to do something when the selection is changed. Now in WPF, in Silverlight, Windows Phone even, there are implementations to make this work. It's often run through behaviors. But there's a little problem we bump into in this case, because behaviors are not supported by default in Windows 8. So what do you do? Well, we kind of have to work around that for the moment. One way to make this work is if you want to handle a selection changed event. You could say, well, when is a selection changed fired? When the property my selected item is bound to change it. That's a dirty way around this. But there actually are a few Windows RT behavior implementations available. I haven't used them, but I will give you the links. The links are in the presentation, so you can have them if you want. There's one on NuGet, WinRT behaviors, that allows you to get behavior support in Windows 8. So that's an event to command behavior implementation, which easily ties into MVVM Lite. There are other ways around this. What we do not want is to handle a selection changed event in code behind and then get some kind of tight coupling to the view model, because that would kind of defeat the purpose. Now there are ways around this. I've seen one of the implementations I've seen was saying, well, what I'm going to do is I am going to handle the selection changed event in code behind, but I am going to ensure that there's another part of my code, another component, responsible for providing me with the correct view model instance. And the general idea behind that is that your view still isn't tightly coupled to your view model, and your view still isn't responsible for getting that view model instance. I'm not completely a fan of this approach, because it still requires me to have event handlers in my code behind. But for the moment, that is one that can work. So what you could typically do then, say, well, selection changed, okay, handle that in my code behind. And that simple IOC container I just talked about, well, I ask him, or I ask it for the instance of a view model I need. I'm not completely convinced of this approach, but it's one I've seen used. So it's still not your view that's responsible for creating an instance of the view model like that. It's still the IOC container that's responsible for that. However, you somehow do say in the code behind of your view that you want an instance of a specific type, or of a specific, that adheres to a specific interface. So that's a bit of semi-tight coupling, or whatever way you want to call it. So there's ways around it, but I still think it's weird there's no behavior support out of the box. So for now we have to kind of work around it. So the last slide on this one, before I go into code, is messaging, and I actually already talked about this. So what's the general idea? You sometimes need to communicate between different view models. You sometimes need to ensure that view model A does something depending on what happened in view model B or the other way around. What could happen is you say, okay, well, view model A, when something happens in view model B, view model A, something other has to happen in view model B, so I need a reference to view model B in view model A. A very bad idea, of course, because you're immediately connecting those two. While, in essence, you don't need to do this. What's the messenger, which is included in MVVM Lite, is it's a component that allows one view model, or one part of your code, let's say, to subscribe to messages of a specific type. Let's put it like that. And when it gets such a message, it should execute code. And any other part of your code or any other view model can then say, well, something happened, and maybe another part of my code needs to do something now. So I'm going to send a message that allows every other part of my code that's subscribed to receive this message, actually receive that message, and execute the code that's needed. What happens with this pattern is that both your view models or all parts of your code know about the messenger, but they don't know about each other. View model A can fire the message, and as far as view model A knows, no code will be executed in any other part of your code, or 10 view models might receive that message and execute code accordingly. The important part here is that there's still no tight coupling or references from one view model to another. They communicate through the messenger and not directly to each other. So again, that's a Facebook example. It's an easy one because everyone knows Facebook. Now, of course, there's more to it than this. But I wanted to give a quick overview in about half an hour about what the basics of MVVM are and why you would use it. So now let's see if we can actually implement this. Do you have the resolution? Yeah, okay. Okay. First thing I'm going to show you is the application we're going to work with today. This is the completed example, by the way. So what this is, anyone remember Woodgrove? No? Never? Nope? No.
I think I've seen it in one of your internet sessions. So
yeah, I use it there as well. Okay, so if no one remembers it, I can say that I completely made this on my own. No, it's actually, Woodgrove was an example app for Silverlight. When Silverlight 2 was released even, I think. It's a banking application. And Microsoft still uses it. So what this is, an application that communicates with the WCF service layer. So you get the service layer, you get all the generated code, etc., etc. That's not what we're focusing on here today. But I've used this to get an application that is built with MVVM Lite, and it includes, as you can see, a variable size grid. It includes a data template selector. So this is blue, this is gray background. So it was an easy way to ensure we can have a bit of the more advanced stuff in here. It, of course, includes navigating. It includes messaging, so sending messages from one part of the app to the other. And it includes some incremental loading. It's actually just a Flickr call to Visuchter. So maybe someone will recognize someone from the pictures here. And in this application, this one also saves data to the object store, uses that if we're offline, etc., etc. So this is the one we're going to work with today. You don't actually have to worry too much about the service and the database behind it. Actually get that. We're focusing on the Windows 8 client app now. Okay, so let's close this. Let's start with this one. Quickly going to show you around the solution. It's very easy at the moment. I've got a catalog service that once hosted on my local host. It's just a web app that's used as a service host. Let's have a look at this quickly so you can see what's possible. This is actually just a service that gets a bunch of categories back, like credit cards and stuff like that. Once you do a call like that, you will get a category group which has a bunch of products. So that's what you could see in what I've just shown you. The notification extensions are used for the live tiles, which we'll get into later. And this is my client application, which already includes a reference to notification extensions to Callisto, which is an open source collection of UI elements, typically. Very good if you want settings in your application, for example, because in XAML you don't have the settings screen as you have with HTML, but Callisto actually includes one. So what have I done here? Actually, not much yet, because we're still going to build this. I have already created all the views we're going to use, and all the bindings are there as well. But as you can see, I don't have any view models yet. So the first thing we need to do now is get MVVM Lite in this application. Okay, so let's have a look at that. You know NuGet? Yeah, okay. And I don't have to explain this. So I'm going to add MVVM Lite through NuGet. Oh, it's online, I need. Oh, MVVM, not MVVM. All right. This is, by the way, a way to get your WinRT behaviors. So, you can find MVVM Lite. Let's install that one. Accept. Close. We now have a view model folder, and we automatically have one main view model implementation, quite empty. We're not going to use that one. Interesting thing here is we also have the view model locator. I'm going to make this a bit bigger. Can everyone read this, by the way? Oh, okay. So they've already put up one example. It's quite easy. Once the view model locator is instantiated, we register the main view model through the simple IOC container. The thing I just told you about, if you want to ensure your view models are instantiated immediately, and not only when the view they are bound to is accessed, you just do it like that. When is the view model locator instantiated? Well, we are going to make the view model locator accessible through via app.xabl, so we can access it as a static resource. So that means my viewModel locator is instantiated once app.xaml is started, let's say. So once your application is started, the viewModel locator is instantiated, which ensures all your viewModels are registered through the simple IOC container. And if you've told them they have to be created immediately, this actually ensures they are created at the moment your application is started. Then we have a property for each viewModel you need. And these properties, through these names, this is what you're going to bind the data context of your view to. So, as you can see, you can go a lot further than what I can show you here now. You can immediately see, for example, you can register services to get your data as well. So that's what I talked about at the beginning. In some implementations, you get, instead of having your viewModel immediately call your generated proxy, some people like to plug in some kind of data service data agent for this. It's a bit too far for this for today, because that will, well, take the rest of the day. What we're going to do now, or what I'm going to do, I'm going to create a new viewModel. I'm going to ensure that that viewModel is the data context of my main page, and I'm going to get data from the service into it. And then it's up to you. So, first thing I need, a viewModel. It's products group page. That's my first view. Let's have a look at that one. Okay, let's not have a look at that one then. As you can see, I've already provided all the XAML, so that's quite easy. So I simply need a viewModel. Let's add one. That's a simple class. I'm gonna make sure I get the naming right. Products grouped viewModel apparently. And it of course needs to implement viewModel base. Now I need to get my data. What would you say is a good way to do this? Should I do it in the constructor? Should I do it once a certain message is received? What do you think? There's no good or bad answer, by the way. Well, if you do it in your constructor, that will mean that depending on what you tell your IOC container, that could mean that once the application is started, immediately all the data is fetched, for example. For some cases, this might be a good idea. I tend to try to get not too much code in my viewModel constructors. So I actually prefer to do this through messaging, or when navigated to the view. That's another way of doing this. But for now, let's try via message, so that I can immediately show you how that one works as well. So I'm going to create a message here. Let's say load data message. That's actually all it is. That's all it needs to do. And I'm going to say, well, view model. You can receive messages of this type. And once you receive a message like this, you should execute load data, for example. I don't need to pass in the message because I don't have anything in it anyway. Okay. And in this method, I'm going to have to call my service and load the data. Now, by the way, just as a side note, what often happens in bigger applications is that you could initially already load a bit of data through an extended splash screen. You've heard about extended splash screens? Yeah, okay. So what actually happens in quite a few applications is that when the application is started, after it starts, you show an extended splash screen to load some initial data you need. And after that, you could send a message to the view models that say, well, okay, I'm now going to navigate to you, and my data is already available, so use that. Okay, so let's load the data. I already have a catalog service reference in place. Catalog service reference dot, what's it called actually? Catalog service clients. Boom, boom. There we go. Get categories, I think. And this won't work. There were people here who didn't have any previous Windows 8 development experience, right? Okay, so what you're probably used to then is that get categories on generated proxy classes would have a completed event you can bind to. Doesn't exist anymore. So what we have now is the async await keywords. You will immediately notice that everywhere in Windows 8 applications. I think the limit is about 50 milliseconds, so every operation that could take more than 50 milliseconds is now async. That means that you're constantly working with, well, that you would constantly be working with completed handlers, which could, of course, quickly end up in a lot of, well, hard to read code after a while, because you will now have to do it for accessing files, etc., for more or less anything. That is why, or that's one of the reasons async await was introduced. There's a bit more on async await near the end of today. Well, probably not, because it's in the extras, but in essence, the basics is you can ensure methods are awaitable by using a async keyword. So in essence, what you're saying with this is, well, this is a method that is awaitable. Well, that can execute awaitable code. What happens now is that once you use the await keyword here, execution of the rest of the code that's in this method will stop until getCategoriesAsync returns completed. That's very simply put how this works. So while you would write code like proxy client dot get categories async completed plus equals and then your event handler, you now simply write it like this, and everything that comes after this call will halt until the call returns. Good thing is it does not block your UI thread. So all of this is done in a different thread. So your UI stays alive. I think that's actually all there is to it. I'm quickly going to look at my completed solution for the correct naming I used for my properties. Let's have a look at that. If you've ever played with the parallel tasks, this is actually its implementation in Windows 8. Behind screens, it's parallel programming framework that's still used. Let's have a look at, how did I call it again? And there we go. Let's just copy paste this because I'll quickly run out of time, I guess. And there we go. So I've got an observable collection of catalog category called grouped and ordered categories. This actually should give me that. I'm going to copy paste this so I have more or less the same code as you will have in your exercises. So what I do here is I quickly add some ordering on title, put that in an observable collection, grouped and ordered categories, and as you will see in the view, there we go. I actually have a collection view source, of which the source is this grouped and ordered categories. Why am I using this collection view source? I could, of course, use a grid view or a list view and simply bind that to my list of items. But grouped and ordered categories, using that one in the collection view source ensures I will be able to use semantic zoom afterwards very easily. You actually need to use this collection view source for the semantic zoom. Now the nice thing is that by using the collection view source I automatically get grouping support out of the box. So I simply state item source is source grouped is true, and I say that items path is catalog products. So what this actually means is I'm saying that all I get in from this collection, that is actually a list of grouped items, in this case categories, and each item in this list has a list named catalog products, which contains the items that contain to this belong to this group. So that's actually what this is. And if I go and look at the grid view, then that's actually simply bind to the grouped items view source, which I just defined a bit higher in my view. So what have we got now? We have a view model. The view model ensures my data is fetched and ordered, and this data is made available to the view through a property on my view model. My data is loaded at the moment the load data message is received. So what I'm missing now is linking the view to this view model and somehow telling it that the data should be loaded. So linking the view to the view model, that's actually done like this. You can simply set the data context to something. Now, this data context should be set to a property I need to get from somewhere. As we said, we made a view model locator available through app.xaml. So let's have a look at that. This is, by the way, added when you add MVVM Lite to your solution. So that's easy to do. I am going to have to change one thing though. This one won't work. That's WPF and Silverlight code, but MVVM Lite still gets that bit wrong. Okay. So I know now that I have a view model locator with key locator available throughout my application, so I can reference that via static resource. And let's see what I named it exactly, so I keep on using the correct naming. Products grouped it is. Okay, I named it products grouped. That's quite predictable. So, in my products group page, I state the data context is the products grouped property actually of my view model locator. So now I somehow need to define this property in the view model locator. Let's see. Not going to use the main view model. So I'm going to register an instance of products grouped view model. There we go. Let's just keep it like this for a while. And let's do it like this. Products grouped, was it? There we go. I now have a property named products grouped on my view model locator, so I can use this one to bind to my view. Okay. I'm going to run this and you will see it won't work. There's a good reason for that. Okay. I'm going to put a breakpoint here to see if it gets loaded or not. Let's start. Okay, so the products grouped view model gets instantiated. How does this happen? Well, actually, you navigate to the products group page. The products group page is bound to the products grouped property on my view model locator. Once that binding is executed, this getter is executed, and my service locator ensures I get an instance of the products grouped view model, which in turn ensures the products grouped view model is instantiated. Problem? I don't load my data yet. So I need to somehow send a message that my data should be loaded. For now, I'm going to send this when we start the app. Might not be the best idea in a real live application, but I need to ensure it gets loaded somehow. So let's send the message. Send load data, was it? And that's just a new instance of it. Okay, so my app is launched. The load data message is sent. So let's have a look at what happens. And normally nothing should happen. go. Okay, so the load data message is sent, and the product group view model is instantiated, but nothing happens. I guess you know why? The problem is the product group view model hasn't been instantiated yet, so it cannot receive that message. And this is where it comes in handy. Well, there's of course different ways to handle stuff like this. You can say, okay, well, only start loading data once I'm already on that page, so I know it's instantiated. Not that good an idea, by the way, because as we will see later, due to process lifecycle management and ensuring your user always ends up where he left off, it can easily happen that a user is in any place in your application without ever going to the first home page of your application, for example. You will always go to example, by the way. So in this case, we need to ensure this one is instantiated immediately.
Is there a performance hit in like instantiating all of your view models at startup if you pass through?
Depends on what you put in them.
If you have like a lot of view models, will it like blow up to startup?
It really depends on what you put in them. If your view model is nothing more than, if the only thing it has in its constructor is registering for a few messages, you won't notice it. If you have a lot of code in its constructors, then yeah. But otherwise, it's just simple class instantiation. So I still have my breakpoints here. The product group view model is instantiated now, and only after that the message is sent. So now it should load the data. It actually does. Let's see if it actually does. There we go. And I've got some data from my service. Okay, so that's it for this demo. Have you got any questions on this?
Can you use the messenger as a replacement for the command stuff? Like
Yeah.
handler,
Yeah.
use the messenger to send a message and then...
That's another workaround. I don't...
No, it's
Yeah.
just one because if you don't have commands baked into the components,
Yeah, you could, but it's, well,
not as simple.
it doesn't sound nice. I mean, if you look at it from an architectural point of view, it's like, you can, yes. Okay, so there's an exercise on this one, of course. You can find the exercises here. That's just linked to my SkyDrive. Well, the first few exercises are on there already. And it's the MVVM one. You actually get the same starter solution I started from. You got that? I'll just, it's this one, exercise MVVM. And the exercise, well, it's actually getting to know how to work with MVVM, using NuGet to add MVVM Lite, and then implementing the view model as I've done for the products group page and for the two other ones. Now, I have foreseen about 1 hour for this. The general idea is to ensure you know how to get started with MVVM. Maybe we could cut the time down a bit, and well, just let me know when you've done one view model implementation. and then we can continue, because I think otherwise we will run very much over time. If you want a completed solution, it's actually just the next solution, PLM, Process Lifecycle Management, that actually builds upon the first one. So it all includes all the view models, etc., etc. And so on and so on. So the starter solution for the next exercise is always the completed solution for the previous one.